Hello, my name is Lin, and this is my 3x2 memory circuit. In this video, I'll be demonstrating and explaining how this 3x2 memory circuit works. In general, a memory circuit stores memory. This memory is stored in the form of bits, stored in bits, and these bits are stored within flip-flops. A flip-flop being a circuit that be held in two different states, 1 and a 0. 1 and 0 is the basis of binary, the universal language of computers. This memory circuit is the basis of all computer memory. Now, this circuit can store up to 6 different bits because there's three memory locations, and each memory location can store 2 different bits. That's why it's called a 3x2 memory circuit. It has 3 different memory locations with each memory location holding 2 bits. Now, I'll be describing the components of this memory circuit. These are my D flip-flops. The D flip-flops are what actually stores the memory in the circuit. If I were to put a 0, let's say in D2, if I were to store a 1 in the 0 section, then that means that this state will change to a 1. And then if it's a 1, my circuit will conveniently say whether or not it is a 1. So this will show up as this will light up, meaning that in the 0 column, that in D0 in the address 2, it's there's a 1 stored in there. Now, this is my address bus. The address bus is what determines in the circuit of what memory location I want to store in. So notice these loose wires, these yellow loose wires. I use them to determine which memory location to store in. So there's A0, there's A1, and A2. If I want to store into A0, address 0, I have to change these loose wires to say 0 in binary, which is just put both of them to negative. If I want to store into A1, then you make this bound binary 1, which is 0, 1, which means one's column is in negative, and then 0 is into positive. And same thing for A2. I just make this 1, which is the 2's column, positive, and the other one negative. Now I'm going to start a demo of this. Now see how there's not enough. See how all these LEDs are not lit up? That means there's no memory stored in it. But that'll change in a moment. Now, I want to store a 1 in address 0. So I change this into a 1. I change it to a 0. So that means I store into memory location 0. Now, I want to store a 1. So I move this loose wire into positive. So that means that it stores into the 0 into those ones place. Now, you see there's no change. That's because in order for the change in memory to occur, I need to press the clock. The clock is represented by a button, and a particular note of the flip-flops is that it only changes state when the clock is pressed, and only when the button is because these memory circuits are positive edge trigger. In other words, only when the button is pressed, not when the button is released. Then it can change state. So I'll change state right now, and see the green LED at 0 lit up. That means now there's a 0, 1 stored within memory location 0. Now if I want to switch into a different state, I just have to switch into a different location that I want to store memory in. Then I just have to move loose one. Then I just have to change which address I want to store to. So I will store a 2 in store 2 in D in address 1. Now that means I have to make it 0 1 with the loose wires. I'm going to have to change this 2. This goes to 0, and this goes to 1 because 2 is 1 0. So 1 0. Then I press the button again, and lo and behold, we have the 2 stored into memory slot 3. Now we want to store 3 in memory slot 2. So just make this a positive. So there's 1 1 or 3 in decimal. Change the memory slot to change the memory slot to 2 and 3. Okay, 1 2 3. Now, at the current moment, yes, you see that there's memory stored in there, but it's kind of useless right now because you can see this portion here. This is the read portion. This reads what data it is, and this is probably going to be like your output to see as a user to know what is being stored in these memory slots. I mean, we see the LEDs, but that's just for your convenience. On a computer, these blue LEDs would be like the screen. You don't see any changes in it without being able to output to there. So how do you output to there? Well, these rest of these ICs, they make up my read portion of my circuits. They allow me to read. This read portion allows me to read from my D flip-flops what memory is being stored in there currently. Now, how do I change from a read state to write state? Now, see this green loose wire? This is by switching to positive. That means I can now go into the read portion of my circuit and read what's up in here. This read portion is also commanded by the address bus because in order for it to know which which portion of the D flip-flop which address to read, I have to determine that address with using my address bus. So I'm going to read from D0. So that means I need to make both of my yellow loose wires to 0. And now I'm going to switch to the read state. So yeah, it reads that there's a 1 in my see, they match. Now I want to read from memory location 1. So I just change the yellow LEDs. And see, it's 2. 2 matches up with what the memory is stored in D1. Now I want to read from D2, and that's a quick change. Put this to 0. Put this to 1. And it's 3. Wait. No. 3. Sorry, the yellow line was loose. So it was able to read perfectly from each different memory location just by me changing which address that I'm referring to. Now, if I want to just go back to, writing in new memory into this, I just have to switch back to. Switch back to 0. That means it returns it to right portion. Now I can change the memory again from at this point. Let's say I want to change D2, the memory slot D2, back into 0 0. So I just put this to 0, this to 0. That means I want to store that one, and I want to store into 2. So let's press the clock like as before. Turns off. That means there's a 0 0 stored in it. Now, this circuit is really basic. It only can store 6 bits at a time. But this is the basis of all computer memory. Now, this circuit is RAM. Why is it RAM? Now, if I turn this off, to turn it back on, notice how all of my LEDs are back on, like I stored no memory in them. That's because that in RAM circuits, or random access memory, it only stores memory as long as there's power going through the circuit. The moment that I turned off the power, there's no more memory stored in it. And if I want to store new memory in it, I have to manually put data back into it. The RAM, now there's only 6 bits, but modern RAM, it can store up to several gigabytes of RAM these days, like 8. So these circuits get much bigger, but we can compress this to such small amounts using silicon and computer programs to build these circuits with absolute precision. So thanks for watching my video, and I hope you enjoyed learning about and seeing a demonstration of my 3x2 memory circuit.